On this 2020 to 2025 F250 with the 7.3 gas engine, P0300 is a random or multiple cylinder misfire type code. In plain language, the powertrain control module may be seeing misfire activity that is not cleanly tied to one cylinder. The truck may idle rough, stumble, feel down on power, or set the check engine light. Broadly, the fault area can be ignition, fuel, air and vacuum leaks, exhaust restriction, engine mechanical condition, basic maintenance items, or the electrical side that supports those systems. Treat any related codes as context, not as a parts list. Before getting deep into P0300, make sure the concern is actually present while you are testing. Do not replace modules or other components just because the path points that way if the symptom is not there at the time. Start with the obvious. Look for anything that matches the customer complaint. Check available OASIS or TSB information, and look for previous repairs that may not have been completed correctly. Then confirm the battery and charging system are working correctly, and make sure battery state of charge is greater than 70% before beginning diagnostics. Next, scan all network modules for system or symptom codes that relate to the concern. If other codes are present, check what they mean first. Circuit-related codes take priority over system or performance-type codes. If there are multiple circuit faults, do not chase each one in isolation until you have looked for a common feed, ground, splice, or shared connector issue. Clear priority faults in the right order before treating P0300 as a standalone misfire problem. Now inspect the harnesses for damage, chafing, and routing problems. Check fuses, circuits, and connectors for continuity and correct installation, and make sure the related components are actually connected. Be careful with connector testing. Use the correct terminal probes. Do not force test leads into connectors, and only back probe when the circuit has to be tested under real operating conditions. Back probing is not the right choice for a single voltage presence check or for ohmmeter continuity testing, because a bad probe contact can look like a real fault. If jumper wires are needed, use fuse jumpers. The recommended universal testing jumper wire fuse is 5 amperes or less, and flex probes are not intended to carry high current greater than 5 amperes. Do not apply power or ground directly to module-switched components unless the diagnostic path specifically calls for it. When the electrical path calls for circuit loading, match the load to the circuit. Circuits carrying approximately 200-1000 M may be loaded with a 250-350 M test light. As a general guide, conductor sizes 24 gauge, 0.5 mm, or smaller are generally used to carry approximately 1000 mA, 1 ampere, or less. Circuits carrying more than 1 ampere should be loaded with a device requiring similar current, like a brake light bulb. Larger conductors matter too. Conductor sizes 20 gauge, 0.8 mm, or larger are generally used to carry 1 ampere, 1000 mA or more. For ground and harness resistance checks, expect less than 2 ohms for most small diameter 18 gauge and smaller wires, and expect less than 2 ohms of resistance for most wiring harness circuits. Remember the limits of the meter. A standard DMM ohmmeter's low resistance resolution, approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. For unintended continuity, disconnect both ends of the circuit and measure between the suspect circuit and ground. Expect resistance greater than 10,000 ohms. Between two unpowered circuits, disconnect both ends of the two circuits, measure between the two circuits, and expect resistance greater than 10,000 ohms. And on voltage drop testing in general, expect less than 5% of circuit operating voltage. If the electrical checks lead you into voltage drop testing, keep the circuit loaded and interpret the numbers correctly. In 12-volt circuits, normal circuit loss is usually less than 0.5 volts, or less than 5% of circuit operating voltage. Voltage readings greater than 0.5 volts indicate abnormal voltage loss, which points toward resistance in wiring or connectors. In a voltage in, voltage out style check, the power side should be within 0.5 volts of battery voltage, and the ground side should be greater than 0 volts but less than 0.5 volts. A reading of 0 volts or source voltage in that test indicates an open circuit. Once the electrical support checks are handled, work through the mechanical and operating basics that can create a random misfire pattern. Inspect vacuum lines and the air intake system for leaks, routing issues, and restrictions. Check hoses for damage, leaks, blockage, and routing. Look at fuel quality, including octane, contamination, and winter or summer blend. Then inspect the fuel tank and fuel lines for damage, leaks, and routing issues. Also check coolant level and quality with the engine operating at the correct temperature. Check oil level and quality for contamination or maintenance concerns. And inspect the exhaust for damage, restrictions, and routing problems. After you correct a fault you actually found, verify the repair separately from the testing work. Recheck the system under the conditions that bring the concern out, rescan for codes, and make sure P0300 stays gone. If a wiring fault was involved, do not just overlay a circuit without understanding why the original circuit failed. Find the root cause and check for nearby wiring damage. The takeaway is simple. For a random misfire, do not jump straight to parts. Prove the concern, prioritize related faults, check the shared electrical and mechanical basics, and then verify the result. For more diagnostic training, visit Diagnostics.com.